So in last class, we have discussed about why do we need to study solution in chemistry. So what is the purpose of studying? And we have seen some examples for solution. So the formation of solution. So what are the different types of forming solution? So in that, the major portion is when you add any salt, any liquid, when you add any solid to liquid portion, that is the solvent mostly will be a liquid and the solid mostly will be a solid. So that was the main case, that was the major example for the solution. And in that type, so we have 9 different types of solution. 9 different types of solution. When the gas is solvent, when the gas is solvent, we can add solute as the liquid, solute as a gas, solute as the uh, uh, solid. Okay. And when the solvent is liquid, the solid may be liquid, gas, solid. So in that 3 types. When the solvent is solid, in that we can add liquid, or in that we can add a gas, or we can add solid to solid itself. So like that, we have 9 major types, 9 major forms of solution. And also the importance of the concentration of the solution that we have discussed in last class. So why the concentration is very important? Because we know that in our yesterday I told that for in our daily water, normal drinking water, we have fluorine in mixed with that water. We have the fluorine dissolved in that water. We know that. But the amount of fluorine should be within the limit. If the amount of fluorine is more, then it causes trouble to our body. At the same time, if there is very low amount of fluoride in the drinking water, it also causes the tooth decay, like that problem. So the concentration of the solution is very important. So we have seen what are the various ways of expressing concentration. Ashik, can you tell me, in how many ways we can write the concentration? So how many ways we can express the concentration? Can you tell me one by one?
Parts per million.
Parts per million, ppm. Yes. Then TDS. Total dissolved solid in water. That also we can say.
Total dissolved solid in water.
Apart from that, that's it now. Have you taken the notes or not? Yes. What are the ways of expressing concentration of solution?
Mass percentage.
Mass percentage. Okay. Mass percentage. Mass percentage, volume percentage, mass by volume percentage, and the main part is mole fraction.
Mole fraction. Mole fraction,
ppm, TDS, mass percentage, volume percentage, mass volume percentage. Okay. Okay, fine. Now, apart from that, we can express the concentration by molarity, by the term called molarity. So expression of concentration, that's what we are looking. Expression of concentration of solution. So we can say by the term called molarity. Molarity means, so when we have the liquid, when we have the solution, so we need to take that volume of solution in liter unit, in the unit of liter. In that, we note that some amount of solute is dissolved in that solution. We know that. And we have to find the number of moles dissolved in that, number of moles of solute dissolved in that solution. So the ratio between number of moles of solute to the volume of solution. So in a given volume, how many number of solute are added? So that's what we call it as the molarity. The unit will be mole per liter. Mole per liter. So mostly this unit we are using to represent to express the concentration, molarity. So this was the one of the important unit. And in here, the mole fraction is the another important unit. And like that, molarity is also the one of the important unit. Both of you are aware about mole, I think. What do you mean by 1 mole? Pooja, can you tell me what is the meaning of 1 mole? Do you know the exact meaning of 1 mole? Hmm. 10 raised to the power of 23. Units means what? What is this? This number. What is the meaning of this number? 6.022 into 10 to the power of 23. What? See, mole is the way of representing it is the unit of amount of substance. What is it? Amount of substance. So that it can be represented. So it can be represented in the unit called mole. So mole is the amount of substance. So it is the unit of representing the how much amount of chemicals we are having, how much amount of particular substance we are having. So, okay, that is mole, amount of substance. So mostly we will be representing amount of substance in gram or kilogram, or we can represent sometimes we can represent by the unit called liter. Am I correct? But here, if I represent by using the unit called mole, so what is the meaning? So what is this number? This is the random number, right? 6.022 into 10 to the power of 23, and that 23 is the very worst number. We can't easily remember that number. It is not like 5, 10, 15. So the 23 is the very random number. So why we are having this complicated number with us in mole? So what is the actual representation? What is this number deals with? So it is 6.022 into 10 to the power of 23 atoms or molecules or ions. Okay, so the kind of the smallest substance. So you may have, say example, if you have chlorine, the smallest particle of chlorine is called as atom. At the same time, if you have Cl2, the smallest particle of Cl2 is called as molecule. Or if you have Cl minus, the smallest particle of Cl minus is called as ion. So it may be atom or molecule or ion. But anyhow, if 6.022 into 10 to the power of 23 atoms are combined together, then it is denoted as 1 mole. Why we took this number? You know, who is the man behind this number? Who is the man behind this number? Avogadro, yeah. So Avogadro. So what is the purpose of using this number in chemistry? So instead of we can represent it by gram, liter. That are the very simple unit, and we know the exact meaning of that gram and liter. Instead of using gram and liter, we are using this number. So why do we need to use this number? Because, say example, if I say hydrogen and oxygen are reacting together and it forms H2O. Hydrogen and oxygen are reacting together to form H2O. So we know that for one part of if I have one part of oxygen, we need 2 times of hydrogen, right? So let it be 2 parts of hydrogen. If we take 1 times of hydrogen, we need to have 2 parts of hydrogen to produce 1 part of water. Am I correct or not? So this is how the chemical reaction takes place when the formation of water. How water is formed? 1 amount of oxygen is joined with 2 times of hydrogen. Am I correct or not?
Yes.
But if I say 1 kg of oxygen, if I say like this, 1 kg of oxygen joined with the 2 kg of hydrogen. When 1 kg of oxygen joined with 2 kg of hydrogen, what will happen? Can we get 1 kg of water? If 1 kg of oxygen combined with 2 kg of hydrogen, can we get 1 kg of water? Is that correct or not? If it is correct, tell me how it is correct. If it is wrong, tell me how it is wrong. Because we know that 1 times of oxygen and 2 times of hydrogen give 1 times of water. So in that same manner, if I take 1 kg of oxygen and 2 kg of hydrogen, so can I get 1 kg of water?
No.
Why? So it is no. Okay. Why? What's the reason? What is the reason? Pooja? Yes, what's the reason? Do you know the question or do you understand the question?
Yeah, I understood the question.
Okay. Now, try to tell me the answer for this. So I have one kind of fruit. I need to make one kind of fruit. Okay, one kind of fruit. Okay, fruit. So this fruit is made synthetically only. It can't be, we can't make this fruit. So for example, I'm saying this. Okay, so I want to make one fruit. That fruit should be made synthetically. Okay, synthetically. That means it can't. We can't get that fruit naturally. So we can't get that fruit from the trees or plants. Okay, that fruit we have to make synthetically. So this fruit is consist of one apple. So one apple and 2 grapes. One apple and 2 grapes. Okay. So actually the shape of this apple like this. The shape of that fruit is like this. So this is the shape. Let it be. In that I just put 2 grapes. Okay. So this is my fruit. This is my fruit. So I want to make this kind of fruit. So that fruit basically consists of, it is the mixing of one apple and 2 grapes. Okay, like this, or you can assume or you can imagine whatever the way of mixing. So basically, if I want to produce one fruit, so let me call the name of fruit as let it be A. The name of fruit is called as A, or you can name anywhere, whatever the name you want, you can make. Okay, so if you want to produce the fruit A, you need to have one apple and 2 grapes. Okay. So as per my previous statement, if you take 1 times of apple, you should take 2 times of grape, so that you will get 1 times of A. Do you understand the scenario? Both of you understand the scenario?
Yes.
So I want to make a fruit like A. So that A should have, if you want to make A, that A should need 1 apple and 2 grapes. So I will take 1 times of apple and 2 times of grape, means I can get 1 times of A. Now the question is, I am taking 1 kg of apple, 1 kg of apple and 2 kg of grapes. Shall I get 1 kg of A? Pooja, the question is for you only. Why? Why? Hmm? I couldn't hear you.
The amount is more.
Sorry, I couldn't get you. What are you trying to say? Hello?
But the amount of apple and grapes.
Amount of apple? Hmm.
And grapes are more.
Okay. So in 1 kg of apple, basically how many apples will be there in 1 kg? Just randomly you can say. Huh? Randomly you can guess. In 1 kg, if you take 1 kg of apple, how many apples you may get? That's a simple question, right? Huh?
Can you hear me, sir?
No. Now I can hear you. Tell me. How? 5. Okay. So 5 apples. Let it be 5 apples. So in 1 kg of apple, we have 5 number of apple. Similar to that. In 2 kg of grapes, let it be 1 kg of grapes. How many grapes will be there? We know the size of grape is very small. So let it be 100.
Yeah.
So in 2 kg, it may be 200. So if you take 2 kg of grapes, that means you are having 200 grapes. So to react with the 200 grapes, how many apples you require? How many apples do you require to react with 200 grapes? How many apple actually we need?
More than 5 apples.
More than 5. That's how many only I'm asking. 100 apples we need. Why? For 2 times of grapes, we need 1 times of apple. So 200 grapes need 100 apples. So this is the exact requirement. This is the exact number. So in this manner only we have to combine together. Instead of, if you take the unit called kg, it won't be helpful. Or else if you take 5 apple, then you should take only 10 grapes. So 5, if you take, that means if you take 1 kg of apple, if you take 1 kg of apple, 10 apple will be something 100 gram. In 1 kg, if I took in 1 kg, if I have 10 grams, means in 1 kg grape, I have 100 grapes. Then in 10 grapes consist of only 100 gram. 100 gram means it is 0.1 kg only. So if you want to represent the amount of apple and amount of grape, if you want to represent the amount of apple and amount of grape, then in kg you cannot write. In kg or in gram, if you write, means 1 kg of apple, that ratio will be something different. It won't follow the 1:2 ratio. If you write in terms of kg, it can't follow the 1:2 ratio or 2:1 ratio. If you take 1 kg of apple, for that you need 0.1 kg of grapes. Or else, if I take 1 kg of grape, so 100 apples means if I take 200 grapes. If I take 2 kg of grapes, if I take 2 kg of grapes, how many apples I need? How many apples I need? We know that 5 apples is 1 kg. So 50 apples means 10 kg. 100 apples will be 20 kg. So 2 kg of grapes, if you take, means you need to have 20 kg of apple. So either you can take 1 kg of apple with 0.1 kg of grape. 0.1 kg of grape, or else no. If I take 2 kg of grape means 2 kg of grape means I have to take 20 kg of apple. Then only the reaction will completed. The reaction can be completed. Am I correct or not? Am I correct or not? Huh? So if you want to have the reactions, if you want to have the reactions between two elements, the numbers only. Now the numbers only will be in the role instead of kg or gram. You cannot put kg and gram in the reaction because that won't follow that won't obey the ratio. Why? In our example, we have oxygen. So the size of oxygen and the mass of oxygen is very high than the hydrogen. So you can't have same number of hydrogen and oxygen if you take 1 kilogram each. If I take 1 kilogram if I take 1 kilogram oxygen, then the number of particles will be lesser than number of particles in hydrogen of 1 kg. Number of particles in 1 kg of oxygen is always lesser than the number of particles in 1 kg of hydrogen. Do you understand my question? Do you understand what I'm saying? So like here only, number of apples in 1 kg of apple is less than that the number of grapes in 1 kg of grape. So we can't have a reaction with kg unit. So we need to have some different unit. So that unit represents the equal numbering. That unit should represent the equal number. So that only this Avogadro came with the concept called mole. For that, he has to decide that he has to determine, say example, I want to have equal number of atoms or molecules. So let me take 1 mole. Let me call 1 mole. See, 1 mole. So 1 mole of hydrogen means it will be 6.022 into 10 to the power of 23 atoms of hydrogen. Atoms are molecules, whatever you are taking, atoms of hydrogen. And same way, if I say 1 mole of oxygen, again it also has same number of count. Sorry. So instead of using gram or kilogram, if we use the number 1 mole. So 1 mole of hydrogen and 1 mole of oxygen both are having same amount of atom or same amount of molecules. Then you can ask, so what is actually 1 mole? So if I want to take 1 mole of hydrogen, how can I take that? He told that what is the atomic number? What is the atomic number of hydrogen? We know that it is 1. And the mass number of hydrogen is also 1. So this mass number only gives the mass to the atom. So what he decides to do, he just take he just take the mass number. Mass number is 1, right? And take 1 gram of hydrogen. Take 1 gram of hydrogen. Find how many number of atoms in that. In that manner only he found that it is just 0.022 into 10 to the power of 23 atoms. Hydrogen atoms. Now it was his assumption. He just took, so hydrogen has the mass number of 1. So we just took 1 gram of hydrogen and checked the amount of number of atoms in that. So he found that 6.022 into 10 to the power of 23. Similar to that, take oxygen. Take oxygen. So the atomic number of oxygen is 8, mass number is 16. Now I want to have same 6.022 into 10 to the power of 23 oxygen atom. So what is my requirement? To have the same number, how much grams I should take. So here he took 1 gram from that mass number. The same way, if he took 16 gram of oxygen, he found that yes, the same number only we can get. Say example, if you take sodium, sodium will be the mass number is 23. So if we take 23 gram of sodium, then again you also have 6.023 into 10 into 10 to the power of 23 sodium atom. Actually, this is the goosebump movement. See, if you take any atom, take the mass number. So mass number is not the amount of mass. Actually, mass number is just the total amount of protons and neutron only. So what he is taking, he just took mass number in gram. Say example, if you take fluorine, so the mass number will be 19. Mass number is 19. So take 19 gram of fluorine. In that also he found 6.022 into 10 to the power of 23 fluorine atoms. Okay, so this 6.022 into 10 to the power of 23 atom is common in all the atoms when you take the mass number in gram. When you take mass number in gram, you found the same number of atoms in every different elements. Say example, if you have chlorine, the mass number is 35. So if you take 35 gram of chlorine, 35 gram of chlorine is again same 6.022 into 10 to the power of 23 atoms of chlorine. So this mass, this 35 gram, 16 gram, 23 gram, 19 gram, and the 1 gram are called as the molar mass. What is that? Molar mass. Molar mass means the mass that can provide 6.022 into 10 to the power of 23 atoms or molecules, whatever. Do you get that? So if you take the mass equal to molar mass, then you will get 1 mole. So this is 1 mole. This is 1 mole. This is 1 mole. You get that? So if you want to react 1 mole of hydrogen and 1 mole of oxygen means, so example, in our case, we want to make sure that 1 mole of hydrogen and 1 mole of 2 moles. I'm sorry. In our case, we want to react 1 mole of hydrogen with 2 mole of oxygen. Actually, it is not hydrogen, so it will be H2 and O2. So for our understanding, I just write, if I take 2 mole of hydrogen, I have to take 1 mole of oxygen. Am I correct? If I take 2 moles of hydrogen, then I have to take 1 mole of oxygen to get 1 mole of water, 1 mole of H2O. Am I correct or not? 2 moles of hydrogen and 1 mole of oxygen can be reacted together because both are at the ratio of 2:1. Both are at the ratio of 2:1. So if you want to represent this in gram, 1 mole of hydrogen is 1 gram. 2 mole of hydrogen is 2 gram hydrogen. So if you take 2 gram hydrogen, in that you have to take 16 gram of oxygen. Do you get that? 2 gram of hydrogen should react with 16 gram of oxygen to get 18 gram of water. to get 18 gram of water. Is that clear? 18 gram, how it came? 2 gram hydrogen, 16 gram oxygen, both are combined together, you can get 18 gram of water. Is that clear? So this is how only the exact reaction can be represented by using gram. So similarly, you can write here, right? 1 kg of apple should react with 0.1 kg of grapes only. And if you take 20 kg of apple, it can react with 2 kg of grapes. The same way only. The same way only. 2 gram of hydrogen means it should react with 16 gram of oxygen. So this is 2 moles of hydrogen, and that is equal to 1 mole of oxygen, and it should be equal to 18 gram. So this 2 gram, 16 gram, 18 gram are called as the molar mass. Are called as the what? Are called as the what? Molar mass. Yes. So molar mass means the amount of mass in gram, which give 6.022 into 10 to the power of 23 atoms, or it which gives 1 mole of that particular atom or molecule. Is that clear? So in chemical reaction, now you can understand why all the chemical reactions, the amount of reactants or products can be represented as moles. You know, now we know the reason for that. Is that clear? So the number of moles is the very important thing in chemical reaction. So you guys just make a note of this. So molarity is a number of moles of solute. So we can add the solute some gram, some 2 gram, 3 gram, we can add the solute to the solution. And that 2 gram consists of maybe 1 mole or 0.5 mole, depending upon the molar mass of the particular compound. Okay. And the one, we have one more way of representing this the concentration of solution, that is molality. What is that? Molality. So molality is, it's just comparing the number of moles of solute, molality. Here we took volume of the entire solution. In molality, we can take mass of the solvent. Mass of the solvent. Solvent is the major portion, right? So in the given mass of solvent, how many number of moles of solute can be dissolved? How many number of moles of solute can be dissolved? So it is mole per kg or mole per gram. So okay, we can represent in mole per gram or mole per kg. Okay, so now we can go through example 2.1. So take a notes of this also, molality. Just take a notes of this, and now we can go through example 2.1. So I hope both of you have the book with your hand. Just read question 2.1. Anyone? Any one of you can read question number 2.1. Yes. Fast.
Yeah. Calculate the mass percentage of benzene and chloride.
Example 2.1. I'm asking you to read example 2.1.
Calculate the mole fraction of ethylene.
So mole fraction of what is that? Ethylene glycol. So they also gave the molar molecular formula C2H6O2, and in exam you shouldn't expect the molar mass. You shouldn't expect the molecular formula like this. They just gave the, if this is the famous name, they just mention the name only. You only have to find the molecular formula. So here they gave, but we can't expect in all questions. If this is the famous name, so ethylene glycol is the famous name, but this compound we will be studying in our 12th chapter, alcohol phenol ether chapter. We will be studying this compound. So for that they gave the molecular formula: carbon 2 times, hydrogen 6 times, oxygen 2 times. So okay, so the mole fraction of ethylene glycol in here, yes. Okay, in a solution containing 20% of C2H6O2 by mass. Okay, and now see this question. Look at the question carefully. So they are asking us to find the mole fraction of ethylene glycol. Okay, so they didn't mention the what is the solvent. So they only gave the solute. Our solute contains 20% by mass. 20% by mass. So they didn't give the solvent. So we have to assume the solvent. And they didn't give the amount of solution also, they didn't give. So the basic formula for mole fraction, what is the formula for mole fraction? It is the number of moles of solute. How many number of moles of solute in total number of moles, in total number of moles of solution. Total number of moles of solution means it basically contains, the solution basically contains two things. One is solvent, let it be A, and the solute, let it be B. So what we have to find? We have to find the mole fraction. We have to find the mole fraction. So mole fraction is number of moles in A by number of moles in A plus B. Is that clear? Is it clear? Yes. Okay. Now they just gave that in that solution 20% only our solute. So they didn't give the solution. So we have to assume the solvent. So we have to assume the solvent. That assumption is valid only because they are asking us to find the fraction only. So we just need to assume one solution. So which solution we can take? Which solvent we can take? The basic solvent is, let us take solvent as what? They didn't give the solvent, right? So we have to only assume the solvent. So let us take solvent as what? What can be taken as the solvent? The best solvent is water. Okay, if they didn't give, we can take solvent as water, H2O. Fine. And also they didn't mention about the amount of solvent we are having. So in that they told that 20% of C2H6O2, 20% of C2H6O2 by mass. So let us assume that totally by mass it is 20%. So the total mass of solution, assume that also we have to assume. Okay, so that assumption is valid only because they are asking us to find the ratio of number of moles. So whatever we can take, that will be correct only. So total mass of solution, that we should take in gram because it 20% by mass only they are taking. So we have to assume the total mass of solution. So since they gave in the percentage, so our assumption we can take as 100 gram. Is that clear? So that is also our assumption. Is that clear? So we can assume that we have 100 gram of solution. We can assume that we are having 100 gram of solution and the solvent is H2O. Now tell me what is the mass of C2H6O2? What is the mass of C2H6O2?
20%.
20% means it will be
20 grams.
20 gram. Fine. Okay. Now the thing is we have to find the number of moles. So we know that 1 mole is equal to molar mass, right? Molar mass of any element or compound is equal to 1 mole. So we have two compounds. One is H2O and another one is C2H6O2. So for that we have to find the molar mass of C2H6O2 and molar mass of H2O, because this mass only gives 1 mole. Now we know that, and we also know that what is mass of H2O. What will be the mass of H2O? If the 20 gram will be the mass of C2H6O2 means what will be the mass of H2O? 80 grams. So now try to find the molar mass of C2H6O2. So what is the atomic number of carbon? Atomic number of carbon is how much? What is the atomic number of carbon? Yes. Yes, Pooja. 6. Fine. So what will be the mass number then? Carbon. If atomic number is 6 means mass number will be 12. Sometimes maybe 13 also. Okay, so basically it is 12. So how many number of carbons we are having here in our formula? How many carbons they gave? 2 carbons. So it is 2 into 12 basically. 2 into 12. Okay. So then what is the mass number of hydrogen? What is the mass number of hydrogen? 1. So totally we have 6 hydrogens. So it is simply 6 plus we have 2 oxygen. So what is the mass number of oxygen? What is the mass number of oxygen? 16. Fine. So it is 2 into 16. So totally 32 plus 6, 38. 38 plus 24. It will be 62 gram. I hope I am correct. And for molar mass of H2O, it is 2 plus 16, again 18 gram. Is that clear?
Yes.
Okay. So now 62 gram of C2H6O2 will give 1 mole. 62 gram of C2H6O2 is 1 mole. And 18 gram of H2O is 1 mole of H2O. Now what we have to find? We have to find number of moles of C2H6O2 in 20 gram. 20 gram. We know that 62 gram is 1 mole. Then 20 gram would be how much? 20 by 62. Am I correct? 20 by 62 moles. Because if 62 gram is 1 mole means 1 gram will be 1 by 62 mole. Then 20 gram means 20 by 62. So if you want to find, simply if you want to find number of moles, what you have to do? If you want to find number of moles for any compound, you have to find the mass by, by molar mass. Mass divided by molar mass. That will be the number of moles. Is that clear?
Yes.
mass by molar mass. So 20 by 62 moles. So you can calculate from that. And similarly, you can find number of moles of H2O. H2O is basically we are having 80 gram. 80 gram. So that is how much molar mass? 18 gram, right? So 18 by, I'm sorry, totally we have 80 gram. 80 gram. So 80 by mass by molar mass. Molar mass is 80. 80 by 80 moles. Okay. So it is 20 by 62 mole. It is 80 by 18 mole. And you can find the fraction. You can divide both the things. You can find the fraction, right? So dash that you have to find. Then now you can find the mole fraction of C2H6O2. C2H6O2. Here you found one value, right? Plus here also you will find one mole, and here. So if I call this is A, this is B, means this should be A by A plus B. That you have to find and tell me the answer. Now find the value 20 by 62 and 18 by 80 by 18 and substitute here. Tell me the final answer. Zero 0.932. Okay. Ashik, do you get the same answer? Ashik. Okay. So now we move on to second question. Example 2.2. Pooja, can you read that question? Fast.
Calculate the molarity of the solution containing 5 gram.
Okay, molarity of the solution they are asking. Okay, containing
5 gram of NaOH.
Containing 5 gram of NaOH. Fine. Containing in 450 ml of solution. Okay, so now we know the formula for molarity. So last question we have seen about the mole fraction. So molarity is something volume of solution in a given volume of solution, how many number of moles of solute presence. So it will be mole per liter. Now we have to find the number of moles. So now we know the formula, right? Clearly we know that number of moles of NaOH, 5 gram NaOH. 5 gram NaOH. What is the formula? Mass by molar mass. Mass by molar mass. So what is the mass? It is 5 gram. What is the molar mass? So for sodium it is 23. The atomic number is 11. Mass number would be actually 22, but it will be exactly, if you speaking, it is 23. For oxygen it is 16. For hydrogen it is 1. So you can calculate 5 by I think 23 plus 16, 29, 39, 40. So 5 by 40, that you can calculate, right? So it will be, you can, if you cancel it, it is 1 by 8 and 0.10. In 10, 1 8s are 8, balance 2, 20. In 20, 2 8s are 16, balance 4, 40. So it is 0.125 moles. And volume, it is 450 ml. So you can find the molarity. So what is the answer? 0.125 gram, I'm sorry, 0.125 mole by 450 ml. 450 ml means 450 divided by 1000 you have to put, because it should be in liter. it should be in liter. So they gave in milliliter. So you should divide 450 by 1000. So it is 0.125 into 1000 by 450, because this 1000 will go upside. Then you can cancel this. It is simply 0.125 by 450. You can calculate this, right? So just calculate it and let me know the answer. Just calculate the final answer. Any doubts on this? Is there any doubts? Okay, so just make a note of this and tell me the final answer. So 0.278 mole per liter, and
Yes.
1 liter is, we can say in 1 decimeter also. 1 liter is equal to 1 decimeter, because 1000 liter is 1 meter cube. 1000 liter is 1 meter cube. So 1 liter will be 1 decimeter cube. Okay, this 1 decimeter cube. So the 0.278 mole per liter we can say, and also we can say mole per decimeter cube. It is dm cube also we can say. Okay, now we will move on to third question. Example 2.3. Ashik, can you read that question?
Yes.
Hmm.
Calculate molarity of 2.5 gram of ethanoic acid.
2.5 gram of ethanoic acid. So, and again, again, I tell you again, in exam, don't expect the molecular formula, because for the famous compounds like ethanoic acid, ethylene glycol, they will just give the name only. So molality of 2 gram of ethanoic acid in how much gram?
75 gram of benzene.
70. See here, benzene, they didn't give the molecular formula. So what is ethanoic acid basically? Ethanoic acid. See, ethane. It is ethane, right? So CH3, CH3. In ethane, instead of one hydrogen, if you have in ethane, if you have COOH group, in ethane will be CH2 carbon should be there. If you have COOH group, then it is called ethanoic acid. So this is CH3COOH, ethanoic acid, and also known as acetic acid. Also known as acetic acid. Now, benzene. So what is the formula for benzene? What is the formula for benzene? It's fast. What is the formula for benzene? C6H6. Now, so they are asking us to find molality. Now they are asking us to find molality. So molality is number of moles of solute, by mass of solvent, So here we don't need to find the number of moles in benzene. Here we don't need to find the number of moles in benzene. If they ask molarity, they have to give the volume. If they ask molarity means they have to give the volume. Here they just give they are asking us to find the molality only. So we know the mass of solvent, because the solvent is benzene. We know it, the 75 gram. So what we have to find? Number of moles in how many gram? 2.5 gram of ethanoic acid. Number of moles in 2.5 gram of ethanoic acid. So this is what we have to find. And so you can find, right? So you know how to calculate so we know the mass, you know how to calculate the molar mass. So tell me the number of moles here, and also tell me the final answer. Tell me the final answer. Calculate it and tell me. And also, I want you to find the mole fraction here. I want you to find the mole fraction. So for mole fraction, you have to find the number of moles in 2.5 gram of ethanoic acid by number of moles in 2.5 gram ethanoic acid plus number of moles in 75 gram of benzene. So again, I gave the formula. Just need to find the number of moles in 2.5 gram of ethanoic acid by number of moles in 2.5 gram of ethanoic acid plus number of moles in 75 gram of benzene. So you can calculate the mole fraction. So calculate the mole fraction also for this question. So I will give you 10 minutes time. Just calculate it and let me know the answer.